This is where we were. Are we live? Oh, hi.
I think I just saw a pop-up that said that we're live, so I'm going to assume that we're live, and I'm going to ask you to share your screen with the game now, Ryan. So, in case anybody is watching, and for the people that are definitely going to be watching the recording later, so our normal fearless leader is having finals right now. So the lead developer of Twilio Quest, Ryan, has been kind enough to join us. Ryan is actually a JavaScript developer. You may have noticed, like on past streams, I've mentioned that although I have written a lot of JavaScript, I'm not technically a JavaScript developer. So it'll be nice to have someone native to the language on to run through some of these missions. And we will also spend a little bit of time later today talking about accepting user input from the command line, because I know that all y'all going to be making console games as your final projects, which is super exciting because I love making games. So, Ryan, I think that you have caught up to where we left off on the last stream. What is next?
Well, first, is this where we left off? Does this look right? I think that I went to the right spot.
I believe that looks right. Yeah,
we said beam 3, right?
Third. Yes, we had just finished the third beam, so I think that you are on track with us. Thank you.
Cool. All right. Is this tiny?
Yes.
Maybe. Well, maybe tiny.
For me, it is tiny. I'll see if I can make it bigger.
Is that any better? There's a lot of weird bordering going on, but it looks, is that better? Or I think there's can do a little zoom here maybe.
The game's big enough. I'm more worried about when you start doing codey things that we will be able to see that, but we can tackle that when we get there.
Yes. Okay. Yeah. So the next thing to do is go up. So we'll go up. Where is it? I believe. So this is our first conversation in the new area. This is going to be kind of weird because I helped and wrote most of this, so I'm going to pretend like I don't know what I'm reading already.
And would you please read the prompts aloud, because they are clearer on your screen than they are on mine.
Okay. Help, help. Can you hear me? And then so there's someone talking to us, the Twilio Quest physicist, whom we cannot see. So I'll respond, I can't see you. What's going on here? Oh, Kevin wrote a lot. Okay. Thank goodness. I know the plot, but I guess I forgot the text. Thank goodness. This physicist responds, thank goodness. Finally, someone noticed I was still in here. The ductypium explosion caused this matter instantiator to go haywire. I was trying to stabilize it when the machine engaged by mistake, causing my body to slip out of phase with this plane of the multiverse. The science behind this is actually quite fascinating, but if you wouldn't mind, I'd prefer to discuss it with you after you've returned my body to normal. And so then we have a few options. Losing your corporeal form sounds unpleasant. How can I help? That feels respectful. Good question to ask. There are control terminals down the hallways to the east and west of this chamber. They must have been damaged during the explosion. If we can get the terminals back online, the matter instantiators should reassemble my physical body. And then I can also ask about retrieving the activation code to stabilize ductypium in the main room. The physicist does have it. The hardware key has gone through the same transformation process as the rest of my body. If you restore my physical form, the activation code is all yours. Okay, that makes sense. Well, I mean, as much as matter instantiator plane destabilization makes sense. So I'm just going to pick a direction. So we'll move to this left one here. So this is object of my affection is the objective here. And so we're going to create a more complex data structure using object literal notation. Literally an object. That's a good one. So our first little task here, I'm going to just look at the to-do list. Do we read the entirety of the objective as well?
No, you don't need to read the entirety. Let's just sum up what we need to do, and then let's go look at the help tab to see what resources are available to us to learn about those things.
Sounds good. Okay, so we're going to make a construction.js file, and we're going to use a construct, or we're going to make a construct function that takes in a string argument and returns an object as described below. And so this is the object described below down here in this table, which is maybe tiny. I think I can zoom this in separately too. No, not from the, but I can do it up here, just not from the keyboards. Oh, I opened a link, but not where it was visible. I'll click the link in a second. So we're going to create an object literal, which we will then now I click the links. And I'll open it and bring it back to where it's visible. Oh, but this is not half screen anymore. There we go. Okay. So an object literal, which is going to be described on the right here on the JavaScript info page, and it has these particular properties. And so now that this is probably also tiny now. Can I get rid of that? Oh yeah, cool.
Hey, nice.
Literals and properties, yeah. So we're going to create something that looks like this, and it's called an object literal, and it will have like the name and age here are properties, and then name is type string here, and age is a type number, and so we have these given types in our table here, and so we'll create an object literal and return it from this construct function in a similar pattern as this. And then there is more information here about object literals in detail. But this is going to probably come up more in the second objective. This one is just about creating one. This looks like it's about manipulating the properties of an object. So I think I will
just show us how it's done.
Just do the thing, yeah. Okay, so I'm gonna open the terminal, zoom in. I made a fresh directory. It's totally empty. I'm gonna open it up in code. I'm gonna overlap the web window. Actually, I like my terminal there, so I will pull quest over here. And then inside of this directory, we have been asked to create a construction.js file. This is probably tiny too. Oh goodness. Okay, the zoom's lagged behind. My computer froze for a second. We're all good. Okay, is this hello world? Is this legible? Should I go bigger?
I can see it.
Okay.
We're gonna hope that means that other people can see it too.
Great. And so the next thing we were asked to do was to create a construct function that takes I believe up here we specified it takes a single string argument, which I think we are saying is C notes name, I believe is what's happening here. What are notes? Oh, literally right beside it. Oh boy. This will be the first argument passed to your construct function. String value, that's not really helpful notes, I don't think. Oh, well, it's backwards. I read it backwards.
Take notes on your notes.
What this is saying is that up here we are passing a string in called name or whatever, but I'll call it name, and then the returned property name is equal to that passed in property. So I was reading that backwards. We could probably make that slightly more clear. So we'll return our name. So I guess.
Don't you need to name it, to name the field name and then pass it the name?
We'll do that first, and then we can talk about that. I should do it that way first. The value of name is going to be the name that passed in, so we can assign an object literal to the value of a variable by putting it just on the right like we would do. Material is a string of human. Assemble is a property, a Boolean property that we want to set to true. Duration is a numeric property that we're setting to 1,000. And so if we pop in here, I wonder if it will have a section on, oh, what is that called? Well, if they don't talk about it here, maybe I will. Yeah. Oh, no, that's different. Property value shorthand. So a lot of times when you're writing code, you'll end up doing this sort of thing where you're writing name twice and age twice, and you'll have that kind of thing where it's a little bit repetitive. And so there's this, in the past year or so, they added this property value shorthand, which lets you, instead of writing name:\name, you can just do name, as long as the property of the returned object matches the name of the variable you're assigning. So that can kind of
convenient. Rarely that is super convenient. However, I will point out that, like with all clever programming things, I'm gonna always suggest that if in doubt, go more verbose. Like, please don't be afraid of taking up more space with your code to make it easier for you to read. So this is super convenient shorthand when you're ready for that, but don't be afraid to use the more verbose way of writing things if that helps you read what you are doing.
both work perfectly fine. They both write code.
They're totally equivalent.
So we can leave it this way for now. And then I believe that is the requirements. Yeah, we did it.
Yay. Good job, Ryan.
I was able, oh yeah, so I've squished Twilio Quest into a very weird oblong rectangle, so, but that's okay.
We just made our hero taller, that's all.
Yeah. Cool, so the other objective to reassemble our physicist here. We did our built-in objects. Oh, so in previous missions, we've used built-in objects like strings and numbers. But so as we get more on the more complex behavior, we kind of want to start making our own structures. And that's kind of where we would come to the, where objects would be used. And in this particular thing, there's a thing called a class. And so I'm going to see what we do here. So our goal is to make a materializer class. And I believe we're going to have more information describing what that means below. So classes are definitely complicated isn't necessarily, how do you talk about classes? They can do a lot, I guess, is what I'm saying. The barest bit of what a class is it's a type of object, but you can do a lot with classes, and they kind of even come with their own object-oriented. If you've heard the object-oriented programming phrase bandied about, that this is the root of that. And like all things, it starts with a less complex building block, which is the class, and then it can get all sorts of complex. So I'm very much avoiding trying to say, like, classes are not simple. They create a lot of pretty wild stuff. But they're sort of the
it's like a Swiss Army knife. You can just use the toothpick if all you need is the toothpick, but just so you know, there's a whole lot more there when you need it.
Yeah, that's what I'm trying to say. I'm always trying to avoid saying something simple, like that's not a helpful. But yeah, it's the most basic building block of this whole sort of object-oriented programming. Thing. Yeah. Yes. So if you're thinking about object-oriented programming, you'll start with class and you build up. And so this is sort of the syntax that we use to create a class. And so if you're thinking about functions we've probably used elsewhere, like with the arrays, where we had like .map and .reduce. But under the hood, there's an array class going on, and that array class had a reduce function and a map function, or string to uppercase is another example, right? And so class lets us make our own things in that way. So kind of this little example here, we've created this say hi function, and you can see that this is very similar to how you would have done like string dot to uppercase. You have your object, your user, or a string in the old way, and you would call the say hi function to do. And now we can make say hi do whatever we want.
Now, the constructor function that you see there, that's not something that the programmer created when they created the user class. That's a default, always there kind of method, and that method is run when you instantiate the class. And you can see that the example that they've got here, the constructor wants you to pass it a name in order to create this class for you. And so when you instantiate this class using the new user, then you're going to pass it the value for name, because that's what we have told the constructor to do here. But the constructor always exists. Even if you don't define it, it will run when you instantiate your new class every time.
Yep. And the thing you want to look out there for with custom objects is the new keyword. That's how you know that the constructor is being run. So we're basically, there's our user class. We make a new user. And then the constructor function is run, like Margaret's saying. If you omit constructor, it's still being run. It just doesn't do anything because because you didn't write anything for it to do. Yeah, so that I think is sort of, I mean, so there's a lot more information here that goes a lot more in depth, but I feel like that's the high level. Yeah, exactly. Right? Yeah, cool. That's the high level bit.
And there's
that
lots
I think
more
we'll use here.
information to dig into if this ends up, if you want to do more object-oriented stuff for your final project.
Yes, and I think even the final objective, I believe, actually goes into this a little more, so I don't want to go too far. But there's a lot of information here, but that's sort of the basic kind of building block that we were kind of talking about before. And so we should go ahead and pop back to Twilio Quest, and we will make our I don't believe that you're going to save that file in the place I want you to. I'm going to do it here. I think it might have, but I know this works, so I'm going to do this. Okay, so we're making the class as specified by Twilio Quest, the materializer class, and we use this this block here to define the properties of the class. So let's see, what did it say? Yeah, our constructor. So this here says create a class called materializer that takes a single string argument. This is omitting some words to be concise, but they're looking for a constructor that takes in a property. And so that's our constructor function here. You can tell code auto-completed it for me because again, that's a standard keyword. So we have our first property, and I'll talk about that in a sec. Yeah, so constructor again. When we go on later, and when we create our physicist.
When you instantiate the class with your new keyword, that's where you'll pass in the variable that gets assigned to the class's target property.
Yeah. So when I call this new materializer, target becomes physicist. It comes in here and I assign it. So this is always a reference. So this is one of the key bits of the object pattern. Whenever you refer to this inside of a function, you're talking about the specific instance. So like if we have materializer 1 and we have materializer 2, and this is biologist, materializer 1 dot target is going to be physicist, and materializer 2 will be biologist. So that's not double, but so you'll have this kind of thing where you have used the exact same class up here, but it has two different pieces of information because of that instantiation thing that Margaret's talked about. You're creating two different materializers that are not linked to each other, and this lets you refer to the current instance. I don't know if that was
the
more, yeah,
that you're interacting with. Yeah. So this always relates to the particular instance that you have just interacted with.
Yes.
So yeah.
Yeah.
It's one of those things that gets a lot easier to understand when you use it, and it's harder to understand when you're just listening to it.
Yeah. So that's sort of the gist, and then let's keep using it. Hopefully it'll become a little more clear too. So when we instantiate this, when we instantiate a materializer using this constructor. I'm trying to be careful with the words I use to reduce confusion.
Having this be a programming keyword is a little bit awkward with semantics.
Yeah, sometimes you'll end up saying a thing when you're like, well, no, I don't actually mean that. I mean something else. This is just a very generic word. An instance function called activate. Okay. So we're also going to, oh, it said a activated. Oh, activate. So this is our function. So before, when we were looking at say hi, or we thinking about to uppercase, we're defining a function just like that. So we're going to reference the activated property, and we're going to set it to true when we call this function. And then an instance function called materialize. So what we're saying here, so okay, let's step back. Materialize is going to do a little bit of logic as well. So the first thing we're instructed to do is return the target. But then the problem further goes on to say that's only true if activated is set to true. So we will do a check to see if activated is true. And it says if activated is not true, we will return undefined. Cool. Okay, so then we've got, let's just go back through our bullet points. We have our target property. We have our activated property that defaults to false. We have our activate function that sets activated to true. And then we have an instance, the final function materialize, which I probably spelled right, that returns the value of target if activated is true. So that's our first else, or our if here. And then inside the else, we return undefined. So
Looks good.
Fingers crossed.
Yay!
We got it.
Good job.
And he's back. Back in a flash.
Excellent.
Okay, wait, I need some water first. Okay, wait. You can see me? You can see me. You did it. You restored my physical form. Here, please take my activation code for the north laser in the experiment room. I'll join you there shortly. I should probably ensure all my internal organs rematerialize properly first. I could have sworn I was a few inches taller. Okay, so we've completed the sort of intro to objects and classes, and we'll head back to activate the physicist laser in the main room. So we are going to do some more object stuff. See what we need. This is our beam 4, still offline. So we need a targeting solution class, targeting solution class here, or file. We need a class called targeting solution, and then the objective is going to describe it a little bit more in detail. We need to, JavaScript classes, object literals. So I believe these are the same links that we were looking at before. And again, there's a lot of information there. Nope, I want this. I want the video game. Hi. You're in the way right now, though. You're going to be grumpy when I move you. I'm sorry. Thank you. What was I doing? Oh, I was reading. So we have our class.
I was just paying attention to your cats because they're cute.
He's snoozing over here. He's being good. The cat in the middle of the keyboard is less helpful in the moment. We're going to take an argument in our constructor. So we should go ahead and define that. We're going to use that. An object literal containing the precise X, Y, Z coordinates. Okay, so we're going to take an object that sounds like something like position. So I'm gonna name it position for now. We can rename it if we would like to later.
And that's going to be an object with 3 properties. Is that right?
That is what it sounds like. This seems to be describing we're going to have an X, Y, and Z property, each of which are numbers. And I don't know what we're doing with them yet, though. In addition, class must implement a function called, so I'm going to, generally what I like to do, especially when like doing classes and stuff, is just kind of write out the skeleton of what everything looks like and then think about how to make them work. Because usually learning about how the following function needs to use the data, what might change how you want to store it to begin with.
Yeah, I find it really useful to think of the first draft of solving a problem as a sketch. So you don't spend a lot of time worrying about, is it exactly pretty? Is it doing it the most clever way? You don't worry about any of that stuff. Just the first one is just a sketch. And you can always come back and make it clean and tight and lovely later. The first thing is definitely just sketching it out so that it does what you need it to do.
Yes, I agree. And so it looks like what we need to do is print out this sort of targeting format here. So we'll print a parenthesis, the value of X, comma, space, value of Y, comma, space, value of Z, and then a closing parenthesis. And it sounds like in bold here, we must match this spacing format exactly. So I'm sure that's a place that accidental bugs will crop up. So in that case, it sounds like I can just go ahead and store a position in an instance property here. We don't seem to need to do any initial transforms or anything. We're just going to reference that data later. And yeah, we want to print. I do not recall. Margaret, do you have any idea if we use the template literal strings or if we've just been doing like concatenation with like pluses and stuff? Is that the way that we've been doing it in this course? Have we done strings in this?
Honestly, I do not remember if we have done. I don't remember our string manipulation. It seems like inevitably we've done string manipulation, but
that's what I was thinking. But I was like, I don't remember. That was like definitely the first stuff that I skipped through really fast to get to this point. Yeah. Okay, so what's happening here is that there's several different ways to manipulate strings to kind of add them together and dynamically create them. Some of them are newer than others. I guess I'll probably just stick with the simpler.
What is their guidance under the help tab?
That's a good question. What do we recommend? Oh, I have my folder there. That's helpful. There's not on strings, probably because we talked about it earlier. Well, that's okay.
Well, then just do it how you would do it.
Yeah, I'll do it this way. I think this will be fine.
And just, you know, a note for our listeners that there are always 5 ways to do everything, and they're all just as valid.
Yeah. Maybe what I can do is show a couple real quick. So the most obvious way here that I can think of is we just got to start printing out the string. So I mean, we have the first thing, we have this parenthesis, and then we want to put X, the value of X, and then we need our comma space. And yeah, I'm just gonna keep going through the variables. I'm also going to put in some new lines here because it's going off the screen.
Because it's really important to be able to read what you're doing.
Yes, and I am zoomed in quite a lot. And then, oops, position is what it's called. Hi, you're back. Thank you for rubbing your face on my monitor. Okay, so even though we're going down like this, these are all just white space. So JavaScript isn't going to care about how that. We're just going to care about the value inside of our brackets and our variables here. So even though we are in a column here, we're going to print in a line. And yeah, so I think that will match our format here as described. We have our 2 parentheses, we have our 2 commas, we have our 2 spaces. So let's find out. All right, that did it. That'll do it.
Yay!
Hi, awesome. You're in the way again, though. I'm gonna have to move you. You're gonna scream. Okay, yeah, I know, baby. You were actually very good about that. You normally don't like being carried. Okay, we have one. We have our original laser to hack now. Got the 3 beams going. I believe that is our current. Right, this is bad. Okay, the final beam. All 3 other ones are online. And so we will create a ductypium. Ductypium is a made-up word that isn't super easy to spell, so I'm just going to copy and paste it so I don't type it wrong. We're going to make another class, so we're going to make that same pattern we've been doing the whole time. And like before, classes are kind of complicated, so we're going to have to scroll past just the to-do list and see what we need to make.
So we're making a class. We are passing it an argument.
Ooh, okay. Yes. So again, we're going to have that constructor. That's sort of our entry point. We can see here we are taking a single string argument, a crystal color. So we're going to go ahead.
We're doing error handling. Yay!
That is very important in the real world. Once a lot of time code doesn't work how you think code might work, and it's always very helpful to know why it didn't work. Otherwise, you're just guessing a lot. Errors are good, even though they're
your friend.
Yeah, even though they feel bad, it's better to get an error and see why you messed up than.
No, errors are awesome. Like, and especially when you write yourself good error messages, that is past you being future you's best friend.
Yes, that is true. So here I am defining these properties because TwilioQuest is specifically instructing me to do so. So I'm going to go ahead and make those initially, even though normally I would finish reading first. Because I think TwilioQuest is going to actually look for these specific names. So we also have this refract function that we were told to make, and we have a calibrate. And then these will be described below. So there is actually some instruction here about the constructor. So this is going to be the first constructor we make that does a little bit more than just assign stuff. So essentially the constructor is a function too. And so at this point I would start doing the functions in order. So I may as well start with the constructor. So we're going to do this validation here. And we want to make sure that the color is only red, blue, or yellow. So let's do that.
So for this kind of error checking, there are a couple of ways you can do it. You can either do it the way Ryan is doing it, which is verbose and lovely, where you do if conditionals against every allowed value, or if that becomes cumbersome, you can also create an array of allowed values that you can check using your conditional, but they are equivalent. So it's really whatever makes it easiest for you to read.
Yeah, okay, so I was going for the simple route, but let's do the allowed colors array. So generally this is sort of the way, and again, both things work perfectly fine. I would usually prefer to do the array approach because it's easier to extend. Like Margaret's saying, like the simple if approach is totally fine, works just great, but it can kind of become cumbersome to maintain as your list gets longer. So if for some reason we decided we also wanted to allow 6 other colors, you'd have to write another 6. Whereas if with this approach, we can just add those items. That's not how you spell blue. To the array. And so now what we'll do instead is say, if our allowed colors array, so these are all of the colors we're going to allow, if it includes the input color up here, so actually, if it does not include the input color, So we are going to throw a new error. And oh, actually, I should follow that link. I don't think we've talked about errors. And so I'm sure that as you've been working with code, you've seen red text show up that tells you did something wrong. That's an error. You can actually throw them yourself, like we were saying before, so that you can kind of warn yourself of problems that might come up later. A lot of times, if you let the code blow up on its own and throw an error, it won't be anywhere near as helpful as me saying right now, you used an invalid color. Like that is a helpful message. Later on, you might just see string warning at line 2, whatever. I'm making up errors. So throwing your own errors is good.
That's the nature of the reason to put in try catch, because just because the system will catch an error down the line doesn't mean it's going to give you useful context. So if you're doing something tricky that you think might throw an error, you can put it in a try catch loop, and then when it catches the error, instead of having whatever the default error is, you can provide additional context to help future you figure out what went wrong.
Yeah. So a good rule of thumb is to catch your errors or throw your own errors as soon as you can. As soon as you can tell something went wrong, because the longer that your bad data goes, the harder it is to trace back where it came from. So that is a great point. And yeah, so here we're.
In this instance, we probably don't need a try catch because we know exactly where we're going to be throwing the error. So we can just skip the try catch and go straight to the throw.
Yes. And so this is the throw keyword. It's a similar thing to return, except it says something went bad. Something's wrong. Stop now. Don't keep going. Figure out the problem. And so what we can do with throw is create, again, a new error object that has a message constructor. And so this is just like the constructor we had before. Whatever text we put here, the error will have that in it. And again, we can make that a lot more helpful than null pointer exception or something. Although I don't think we get those in this language, but whatever. We can make a helpful error message. And I believe that we do not have, it doesn't look like we have any. I'm just going to double check to make sure we don't need a specifically defined error message, which I don't see. So I think we can say whatever we want. And so I guess what I would say here is that color is not in allowed colors list. And then something that you can do even more helpful, like Margaret was saying, is add some context to your error. Oh, I'm doing it in the wrong spot though. I'm just going to keep doing strings this way. Also, white space can be good too to keep things keep things on the page. And so what I'm going to do here is actually add the color variable here. So what we'll see now when we log this error is the color, and then actually see the exact input we passed in is not allowed in the colors list. So that gives you a little more context. So you can help track back what error happened. So let's see. That is the requirement here. The constructor should throw an error. That's any other string. Yep. And then if it's helpful, this pattern in JavaScript at least is called a guard pattern. And so what you'll do is you check, instead of seeing if something's allowed and then doing it, you see if it's bad and then throw an error immediately. And then from everywhere further on in your code, you can just assume that everything's working because you proved that it was good earlier. So that's a little pattern name. Let's see, and then that.
Now we need to figure out what our refract and calibrate method needs to be.
Yes, we are moving on. So the refract method will take another string argument. So this is going to be our, I guess I'll just call it refracted color to differentiate it from our main color. Okay, so what we're seeing here is actually a repeat. We want to make sure the refracted color is red, blue, and yellow, just like we wanted to do up here. So at this point, I think what I should do now is make a function to copy that logic so that I don't have to rewrite the same thing again. And so I'm just going to make
a color check method.
Yeah, I'm going to say is valid color, and I'll take in a color, and then instead of putting this logic up here, I'm going to put it in a function so that we can reuse it. And I'll say, well, I guess it should be, because it's going to actually throw an error, so it shouldn't be is valid color. It should be, let's call it color check. Oh, actually, that is the nomenclature I would expect in JavaScript, I think. So validate color will throw an error. Otherwise, it'll keep moving on.
And now you can put that exact same line into your refract method, and it will automatically do the thing.
Yes. Yeah. So.
And it means you only have one error method to troubleshoot if anything goes wrong with your error method, instead of having to like do like a find and replace across 10 different methods that all do the same thing.
Right. Not to mention like what happens if you need to allow orange, and then you have to go to every place where you wrote this array and update it again. So always good to encapsulate or encapsulate that logic. Put it all in one place.
Reduce and reuse, just like with recycling.
Yes. Recycle your code. So we did this just like the constructor, and we're going to return a single string, which is okay. So we're combining colors here, which is the color produced by the combination of the color and the color passed in. So we're going to take a refracted color, make sure it's valid, and compare it to our valid one, and return the two. It's not a product; it's a refraction, I guess. It's not math; it's color theory. And so here's our color theory reference here. And so what we'd like to do is check our color combinations. And so I'm trying to think of a way that is not the over-engineered way that I did it when I made it. So basically, a common issue I see when some folks have trouble with this is that they check if this dot color. So like, I guess I'll just explain. If this dot color is red and this dot refracted color, or nope, it's not this, it's a passed in property, is blue, then return purple.
Shouldn't we handle our first instance? Shouldn't we handle the first thing that could happen being if the refracted color and the object's color are the same?
Yeah. I just wanted to, since I've already got it here, I just wanted to point out this is true here, but also it can be true that color is blue and refracted color is red, and we're going to still return the same logic. So that's the number one bug I see when folks do this. The case that Margaret is talking about is one where our internal color is the same as our refracted color, and in that case, we can return either one, right? Because they're both the same. So if you have red and you refract it with red, you still have red, and so that is our first case. And so
now, in order to deal with the second issue that Ryan is looking at, which is the fact that it can work in either direction if one of them's red or the other one's red and the other one is blue and the other one is blue. So the way I would do this, Ryan, correct me if I am over-engineering, because that is absolutely a thing that I do. But my inclination would be to take the object's color and the passed-in color and put them into an array, and then simply check if the array contains red and blue, return purple. If the array contains red and yellow, return orange. If the array contains yellow and blue, return green.
So that's actually how I did it exactly before. I was worried that it was over-engineering, but if you did the same thing, we're going to do it that way. Yeah, because I wasn't sure if like that was too much, but so the reason that, so to be clear, like there's always two ways to do things. The other thing that would work too is you could do this for every single combination. So I figure since I have it written here. But the problem is that now you have this sort of amalgamation of two and statements, and they're joined
Connected
by
with
an or statement. And this, I mean, I tried to format it nicely, but it still is very.
Again, it just
It's hard
boils
to
down
understand.
what you find easiest to read. If you find the two ands combined with an or to be easier to read than putting something into an array and then checking the contents of the array, do the ands and ors. It really is equivalent. It's just a matter of what is easiest for you to read, because that's what's going to make it work faster and be easier to change later, is whether or not it makes sense to your eyeballs.
Right. Exactly. Yeah. And then the other caveat with that will be, at some point you will work with teammates, and then together you will all decide what is the easiest with your collective eyeballs. But at this point, whatever makes sense for your eyeballs is great. And so what Margaret was suggesting here is that instead of doing this version, we're going to create an array that has our two colors in it. And we're going to use the includes logic similar to what we did before, because what this logic is saying, we don't care which one comes in which order. And we can do that slightly in a way that is clear to me, at least, and Margaret. We don't really care about the order, so we would rather just say, do our colors combinations include red, and do they include blue? We could care less what order they're in. That doesn't matter to our logic right now. And so this is totally just exactly equivalent to what we did before, but to at least the two of us, it reads a little clearer. And so we have the red and yellow returns orange combination, returns orange, not oranger. And our final combination is blue and yellow. I will, for the sake of the diagram to my right, I will flip them. And that returns green. And those are our cases.
Now, just for the sake of following up the way we did previously, the reason that this is okay, even though all of the returns are encapsulated in a conditional, is because at the very top, we made sure that we were going to get one of the things. Because we put that validator at the top, we don't need to have a final return in case none of the conditionals matched, because the conditionals we are sure are definitely going to match one of them.
Yep, and that's thanks to that sort of guard pattern is a way, if you want to find more information about it, if you search the guard pattern, you'll see that. So it's sort of the whole process of get your error handling out of the way and then write your nice code that assumes everything's perfect below. And again, there's plenty of times where things aren't quite as neatly encapsulated at this, and you might end up with one of these throw new error at the very end, just in case, so that you can be aware something slipped through.
Go on to calibrate?
Yes, I think that was all of it, right? Yeah, I believe so.
I think so.
So we're gonna stabilize the ductypium crystal. So we're going to take a single argument, an array of numbers. So I will call it numbers. We would like to sort the numbers. We're going to sort the numbers, multiply by 3, and then assign that result to the calibration sequence variable we defined a while ago. So this won't return anything. This is instead going to modify a property on our object. And we have some example code that we can run our object through just to verify that things work as we expect before we submit. So we'll do that after we do this. And so here we're going to our eventual, well, how about we can do it if I can type const result. We would.
I need to plug in my laptop, so I'm going to disappear for like 30 seconds.
Okay. So what we're going to do is sort, and then we're going to use array functions here. And so the next thing we'd like to do is use the map function that we used before and multiply every number by 3, because the map iterates over everything and then returns a new array. So that should give us our result. And so one thing that might happen here, one thing that does happen that I am not sure if this Twilio Quest objective is taking into consideration is the sort function can be a little peculiar sometimes. So I'm going to check. We don't mention it specifically, so this might avoid it. This is just, oh, this is the MDN guide, just the homepage as a good reference for the future.
So we have absolutely used map before. So
there's a peculiarity with sort where it is a little dumb sometimes, and it will sort numbers as if they were strings by default, which can usually look like it worked, and then you can find out that it didn't work later. So I guess what I can do is say that I feel like this objective is gonna work anyway and not care, but we should go ahead and just talk about it real quick. Actually, why don't I go to, so when in doubt, you say, you type, nope, oh, I don't search my Mac, I don't want that. You you say MDN array sort, and you type it in, and then you look at the reference here. Something I have done to my computer has made things slow, but it seems like it's okay. And so what you'll see here, if you look at this very first paragraph, and it's not something you would exactly assume, the default sort order is based on converting the elements into strings. And with numbers, we don't want that, because that would sort, you would sort 1 and 11 and 1,233 before you would sort 2, because 1 comes before 2, and it's comparing it in a string format. So instead, what we'd like to do is sort lets us pass in our own custom function to compare. So it's called this compare function. And we have this first element and second element. And if you actually come onto MDN here, it's a great place to look, because half the time the little thing that you're trying to do is already written by somebody else right here, and you get to see it with reference. And so here is the exact example function that I was going to make. So instead, why don't we just, instead of me writing it, why don't we just paste their function right in right there. And so what that'll do is let us actually compare numbers numerically instead of turning them into strings and comparing them. There's a lot of peculiar default JavaScript behavior that dates back because of reasons. And so now that we have our correctly sorted information, let's assign it to the calibration sequence. And then let's run some test code. So I'm going to open the well, I shouldn't have opened the terminal yet. Get out of the way, terminal. We're going to paste the test code in here real quick. So these are some test cases that I'll just cover up Twilio Quest for a sec. Yep, so here's the try catch block that Margaret was talking about earlier. We're going to attempt to make a ducktypium class with an invalid color. And then we're going to test each of the functions here. And so when I go ahead and run this ducktypium with node, we should see the expected outputs. So we can see our error handling caught the pink. Color must be red, yellow, or blue, showed up right there. We log the initial color and we get red. We refract the initial red with blue and get purple. We refract red with red and get red. And then we do our calibration sequence of 351, and it turns into 3915, just like we want. Cool. So it looks like everything is functioning. It's usually a great practice to do a little test before you put the bow on your code. So that's a great habit to get into. And we will see if Twilio Quest agrees.
Yay! Good job.
We did the thing. And so now the JavaScript training lab is much less on fire and stars poking through and everything. And so now everybody is returned to their stations. It's incredible. The ducktypium molecule is stable. We did it. I know you must hear this all the time, but you're a real hero. Our team and every resident of the cloud owes you a debt we can never repay. All in a day's work. I I hope not. How many reality-threatening crises do you have to deal with in an average work week? Oh, and then we noticed that the laser was sabotaged, and that's what caused the explosion.
So there's more, there's basically always more Twilio Quest that you can play, and I highly recommend that you dig into it. But I'm going to take the last few minutes to talk about something that you are definitely going to need when you are tackling your final project. So your final project, I understand you are going to be making a console game, as in not like a Nintendo console, but like the command line console, which is super fun and something that is near and dear to my heart because writing games is absolutely my favorite way to learn new tech skills. So one of the things that you are definitely going to need to use when you are creating a command line game is you're going to need to be able to accept user input. Now, if you're doing this in a web page, then you would use JavaScript's prompt method, but because you're going to be using the command line, you're instead going to either be using Redline or you're going to be using console read write. So I understand you're all using Node. And if you are using modern Node, then you can just require console read write, and then you can use whatever you assign that to both read and write to the command line. However, if you're using an older version of Node, then you're going to realize that that is just a wrapper around Readline. And in order to create your own console rewrite, you're just going to include Readline, and then you are going to tell it that its input is process.standard in, and then its output is process.standard out. And that will basically create exactly what the more modern Node creates using console read write. I don't know if that was super clear. Ryan, did that sound super clear to you?
Yeah, I got it. Yes, you did a good summary. Readline is the way that's tried and true, and it works. With most JavaScript things, there's a modern thing where someone wrapped the old, slightly cumbersome thing in a pretty new wrapper, and it's a little smoother to work with. But the old ways work just as well.
So I will go ahead and copy into the chat. I'll go ahead and open up the Bit Project Twitch so I can copy both of those ways into the chat, just so you can more easily search up your own documentation later, because I know that sometimes seeing something makes it easier to interact with.
And yeah, I did copy. I went ahead and copied. Node has official documentation, and I went ahead and copied their Readline demo. Oh, I'm hearing myself.
Sorry.
Nope, we're good. I'm gone. So this is the official. Like, this is the minimum little Readline you can do. And so it's a little strange in some ways, but it works just as fine. You can see Readline. I type .question. I type in a question, and I wait for a response. So. As far as old things or cumbersome things go, it's not the most cumbersome. So I believe that this is actually a little newer of something, because it's actually I think there might even be a more legacy way. So you're in good hands.
Yeah. So he's got a great example of Readline up, and basically, if you have a modern Node, you can just at the very top where he's got const Readline equal require Readline, you can instead have const Readline or const IO equal require console read write. Let me double check and make sure I'm saying, console read write. So if you require console read write instead, basically that just takes care of what Ryan has done on the first 6 lines in one line. It's just a wrapper for the exact same thing. So just keep in mind, 5 ways to do everything. They all work. Feel free to do whatever you find first or whatever reads most easily to you. And remember, you've got mentors that are so happy to help you out. So please do not be shy about asking questions. We just want you to be successful. So let us know what's up and we will help you do the thing.
Cool.
I think that's it.
JavaScript.
Yeah, that's JavaScript. Done. Congratulations. You know enough JavaScript. Honestly, as long as you develop a comfort around searching for questions and reading documentation, congratulations, you are a programmer. That is the heart and soul of being a programmer. So embrace that part of the journey and know that you are absolutely training the most critical skills every single time you do that.
Yes. And to be clear, I still do that every day. I was doing it just now on stream. We're always learning.
Yep. Learning and growing are always. You will never meet a programmer that has done learning all of the programming things. That never happens. That is not how the world works. So enjoy being a student of programming, because that is being a programmer. We are all students forever and ever.
Yep.
So thank you for joining the stream, and I hope you all make really awesome, fun games that I get to see later. Bye.